Let's have a look at the shape of AB5 molecule, where A is a central atom which has to be bonded to 5 B atoms. 3 of them are placed at the corners of regular triangle and 1 at the top and 1 at the bottom of the plane. Now the shape looks like trigonal bipyramidal. These 3 bonds are called as equatorial bonds and these 2 bonds are called as the axial bonds. Axial bonds are always longer than the equatorial bonds. Example of AB5 kind is PCl5, where phosphorus has got 5 electrons which are bonded to 5 chlorine atoms. Let's see the next derivative of AB5, which is AB4L, where one of the bond pairs is replaced by a lone pair of electrons. Let me take this trigonal bipyramidal structure and replace one of the bond pairs by a lone pair and see what happens to the shape. When we replace one of the equatorial bonds by a lone pair of electrons, the trigonal bipyramidal shape becomes a seesaw shape. Shape of AB4L is seesaw. An example of AB4L is SFO, where sulfur has got 6 valence electrons, 4 of them have gone bond formation with fluorine atoms and left with a lone pair of electrons. The next derivative of AB5 is AB3L2, where 2 of the bond pairs are replaced by lone pair of electrons. We have already replaced one of the bond pairs by lone pair of electrons. Let's see what happens when one more bond pair replaced by lone pair of electrons. Now, the arrangement of electron pairs is still trigonal bipyramidal. The shape has changed to T shape. ClF3. Chlorine has got 7 valence electrons, 3 of them are gone for bond formation and left with 2 lone pairs of electrons. The next kind of molecule we are going to have a look is AB6 type, where A is a central atom bonded to 6 B atoms. The most appropriate arrangement is A at the center, 4 of them arranged at the corners of a square and 1 above the plane and 1 below the plane. And this shape we call it as square bipyramidal, or otherwise called as octahedral shape. An example of AB6 is SF6, where sulfur has got 6 fluorine atoms. All the 6 have gone for bond formation 6 fluorine atoms. The next one is the derivative of AB6, where one of the bond pairs is replaced by a lone pair of electrons. Let's see what happens when one of the bond pairs of octahedron is replaced by a lone pair of electrons. See, the shape has become square pyramidal. The shape of AB5L is square pyramidal. An example of AB5L is BrF5. Bromine has got 7 valence electrons, 5 of them form bond with 5 fluorine atoms, left with 1 lone pair of electrons. Let's see the next derivative of AB6, where 2 of the bond pairs are replaced by lone pair of electrons. We have already replaced one of the bond pairs by lone pair of electrons. Let's see what happens one more bond pair is replaced by a lone pair of electrons. The shape now becomes square planar with 2 lone pair of electrons. The shape of AB4L is square planar and its example is XeF4. Xenon has got 8 valence electrons, 4 of them goes for bond formation. It's left with 2 lone pairs of electrons. To sum up, by valence shell electron pair repulsion theory, let's see the shape of these molecules once again. AB6 will take square bipyramidal or octahedral shape. AB5L replace one of them by a lone pair. This becomes a square pyramidal structure. And in AB4L2, if 2 bond pairs are replaced, it becomes a square planar shape.